All right, get ready for a Python puzzle that looks super simple on the surface, but, well, it's got a few tricks up its sleeve. We're going to follow a single variable on a wild journey as it completely changes its identity, literally shape-shifting from one data type to another in ways you might not see coming. So let's dive right in. Okay, here's the code in question. It all starts with x equals 5, and then we do a few things to it. Now, before we break this down together, I want you to take a good look at it. What's your gut feeling? What do you think the final value of x is going to be? Seriously, pause and take a guess. I have a feeling the real answer might just surprise you. The only way we're going to solve this little mystery is to go step by step. And here's the key. We're not just going to track the value of x, we're also going to track its type. Because trust me, that's where all the interesting stuff happens. So let's start at the very beginning. Okay, this table here is going to be our guide through this whole process. And step one, super straightforward. The code is just x equals 5. Python creates our variable x and assigns it the integer value of 5. Easy enough. So right now, the value is 5 and its type is an integer. So far, so good. And here we go, our very first transformation. We're about to add 2.0 to our integer x. Now pay close attention to that little decimal point. That point 0, that's the crucial detail here. It's about to change everything. And check this out. When Python sees you trying to add an integer to a float, that's a number with a decimal, it automatically promotes the result to a float. It does this to make sure no information, no precision gets lost. So just like that, our x is no longer the integer 5. It is officially shapeshifted into the float 7.0. Okay, so x has gone from an integer to a float. That's pretty standard stuff in programming. But this next step, this is where the real surprise is. Our little variable is about to have a full-blown identity crisis. So take a look at this line of code. It's actually a 2-for-1 deal. First, it's taking our variable x, which is currently 7.0, and it's forcing it to become a string with that str function. Then, it uses the plus operator to stick the string 3 onto it. And now, look at our table. The plus operator's whole job just changed. Since we're working with strings now, the plus sign no longer means mathematical addition. Nope, now it means concatenation, which is just a fancy way of saying glue them together. So the float 7.0 becomes the text 7.0, and we just stick the text 3 right on the end. And just like that, our variable x is now the string 7.03. It's officially text. All right, so now for the next twist. We have a string. What on earth do you think happens when you try to multiply a piece of text by a number? Is Python just going to crash? Is it going to try to do some weird math? Let's find out. The next line is x equals x times 2. So we're taking our string, 7.03, and multiplying it by the integer 2. This is such a classic Python trick. And this is a perfect example of something called string replication. See, in Python, when you multiply a string by an integer, it doesn't do any math. It just copies the string that many times. So 7.03 times 2 literally just gives you 7.03 followed by another 7.03. So our variable is still a string, it's just a little bit longer now. All right, we've seen x start as an integer, become a float, then turn into a string, but it's not over yet. For its grand finale, it's going to transform one last time into something totally different, a list. Now this line, x equals x, might look a little weird at first glance, but those square brackets, they're incredibly powerful in Python. They're how you create a list. So what we're doing here is basically saying, hey, create a new list and put the current value of x inside it as the very first item. And this is the crucial point. X is no longer the string 7.03, 7.03. It is now a list that contains that string as its one and only element. You can even see it in our table. See the square brackets around the value? That tells us it's a list. Okay, we are at the very last step. We're taking our new list, x, and we're using that plus operator again. This time, we're adding it to another list, a brand new one that just has the integer 10 inside it. And for our final trick, we see that the plus operator behaves with lists almost exactly like it does with strings. It doesn't do addition, it does concatenation. It just joins the two lists together. So our first list gets combined with the second list, giving us our final result, one single list that now has two different things inside it. After all those twists and turns, we have officially traced our variable from the very beginning to the very end. We watched it change its type 3 separate times. So, what is the final answer to our puzzle? And there it is. The final value of x is a list. And inside that list, we have the string 7.03, and the integer 10. That is a long, strange journey from that simple little number 5 where we started. And if we look back at our original problem with all the options, you can see that our step-by-step trace led us right to the correct answer. It's not some kind of black magic, it's just about patiently following the rules of Python, one line at a time. Now, this little puzzle wasn't just some random brain teaser. It's actually a fantastic way to understand two really important concepts that make Python so powerful and flexible. And yeah, sometimes a little surprising. The first big idea is called dynamic typing. This is the main thing we've been watching this whole time. In Python, a variable isn't locked into being one type forever. Our variable x was an integer, then a float, then a string, and finally a list, all in the same short script. This gives you amazing flexibility, but it's also why you have to be really careful and keep track of what type your variable is at any given moment. The second concept is operator overloading. This sounds complicated, but it's just the fancy name for why the plus sign and the multiplication sign kept changing their minds about what to do. The plus sign knew to add numbers, but it also knew to join together strings and lists. The asterisk sign knew to multiply numbers, but to repeat strings. The operator's job completely depends on the context, on the data types you give it. So what are the key things to take away from all this? First, always remember that Python variables are basically chameleons. Their type can and will change. And second, operators like plus and star are multi-talented. They do different jobs depending on the situation. So whenever you're writing code, you've got to ask yourself, what data types am I actually working with right here? Because the answer to that question changes everything. And think about it. This whole incredible transformation happened in just a handful of lines of code. It really makes you wonder, right? What other simple-looking code is out there, just hiding some surprisingly powerful behavior? Keep exploring, keep questioning, and thanks for tackling this puzzle with me.